Today, I'd like to take you through two examples of compound interest. Before we start these examples, I'd like to give you some formulas. The formula that we are going to use for compound interest is this. A equals P times 1 plus R divided by N raised to the NT power. So what do these parts stand for? A will represent our final value. How much money do we have after we have applied the compounding interest? P is going to represent our initial investment. R represents our rate. The rate will be given to you as a percent, but you're going to need to change it to a decimal. You'll see N in both of these places. I'm going to come back to that. T represents our time. Time in these problems will be in terms of years. So N tells us how many times we will compound the interest in a given year. Another formula that you're going to need in order to work these problems is compounding continuously. If a problem says that the interest compounds continuously, you will use A equals P times E raised to the RT power. Again, A is going to represent your final value. P is your initial investment. E is not a variable, it's a number, and so we will not be replacing it with a value. R is our rate, which we will express as a decimal, and T is our time period in terms of years. Let's take a look at this first example. Let's identify the different parts that we're going to put into our formula. The person invest. This is going to be our initial investment, P, in an account that earns 5.2%. This is our rate, and we need to express this as a decimal. It's going to earn this rate annually, 1 time per year. So N will be equal to 1. Find when. That means that we don't know the time period, so that's what we're going to be solving for. The value of the investment reaches $6,000, so this is my final amount, or my A. Let's set the problem up. We're going to use logarithms in order to solve the problem today, but you could use your calculator to do this also. $6,000 is equal to 2,560 times 1 plus the rate divided by N raised to the N times T power. Let's clean this up. First, I'll combine the things that are inside my parentheses. Since this is a 1t, I'm just going to express this as t. So I have 6,000 equals 2,560 times 1.052 raised to the t power. In this case, I know I want to solve for t, but t is an exponent. My variable being an exponent gives me a couple options, and one of my options is to use logarithms. In my previous problems that I've worked with you, I told you should identify the part of the problem that you want to solve for and then isolate that. So let's start this problem by dividing 2,560 on both sides. You may want to pull out your calculator to do this. You can see I have already done this for you. I'm going to encourage you not to round at this point. Go ahead and write down this decimal exactly as you see it. I no longer need the parentheses since there isn't a number on the outside, so I'm just going to write 1.052 raised to the t power. If I could get these base numbers to be the same, then the exponents would be equal to each other. But there isn't a way to re-express these as a number to a power, so I'm going to use logarithms. Whatever you do to one side, do exactly the same thing to the other. The reason we take the log of both sides is because there's a property that tells us an exponent can come to the front as a coefficient. So now, the t is a coefficient times the log of 1.052. To solve for t, I'll simply divide this logarithm on both sides. Since the problem does not tell us what to round to, I'm just going to have you round to the nearest tenth. The key thing to remember, if we're solving for t, it is the time period in terms of years, so make sure that you put the appropriate label on your answer. Let's go ahead and enter these logarithms into our calculator. Make sure that you close the parentheses before you divide the other logarithm. Now let's round to the nearest tenth, 16.8 years. I'm not going to work these problems, but I want to point out some things that you need to be careful and watch for. Notice in this problem that it says the annual interest is compounded semi-annually. When they use this word, they're telling you that they compound the interest twice per year. So in this case, n is going to be equal to 2. These two problems also use compounding in a time period. This is compounded daily, which means n would be equal to 365. And in number 7, it's compounded quarterly, which means n would be equal to 4. So now I'd like to work a problem where the annual interest is compounded continuously. I gave you a formula for this. A equals P e to the RT. So, a person invests $6,750. This will be my P. My rate is 6.23 or 0.0623. The annual interest is compounded continuously. Find when the value of the investment reaches $15,000. So let's set up our problem. 15,000 is equal to 6,750 E 0.0623 T. Again, since my variable is an exponent, I'm going to use logarithms to solve this. Isolate the part of the problem that you want to solve for. So let's start by dividing 6,750 on both sides. I get a repeating decimal, and I'm going to show you how to use this in your calculator in just a second. For right now, we'll just write down the value. 2.2 repeating. So again, since I cannot make the bases the same number raised to a power, then logarithms is my best method to solve this. I'll take the log of both sides and I'll bring my exponent to the front as a coefficient. Now don't forget, if ln e shows up in your problem, we know the answer to this. Ln e is equal to 1. 1 times this will just remain the same, 0.0623t. So now all I have to do to solve this is to divide both sides by this decimal. So let's talk about how to use this previous answer. If I need to do the log of 2.2 repeating, I can select ln and then use my upward arrow button to select the number that I want to insert. When you hit enter, it will bring it down into your problem. We'll close the parentheses and then we're going to divide by 0.0623. Round to the nearest tenth, and we're going to have 12.8 years.